Hi and welcome all. My project is about predicting the stock price using the machine learning. So, let's get started with a quick introduction. So, when we think about the machine learning, the first thing that comes to our mind may be an evil computer that will take over the world. But, as said by Pedro Dominguez, the real question is not that the computer will get smart and take over the world. But the real problem is that they are too stupid and they have already taken over the world. So, if a computer makes a mistake, it is capable of making a mistake millions of times a second. So, we don't want our computer to blindly follow instruction. We want the computer to go into a self-learning when they are exposed to new data. So when we talk about machine learning is all about improving the performance of a system with experience. And this experience comes when the system can learn from the data it is exposed to. So machine learning is very powerful, but it's not a magic. It relies on the data to which the system is exposed to make a decision.
So, as I said before, my project is about predicting the stock prices. So, in order to do so, the steps for my project will be as follows. I'll start with installing the platform, and then I'll load the dataset and try to visualize the dataset. If required, I'll readjust the dataset, and I'll define the features and the label, and based on it I'll create a training and the testing sets. I'll try to evaluate some algorithm, and at last will make the predictions. So I'll be explaining more on this as I'll give the demo. So now let's get started with the demo. So the first step is installing the platforms like SciPy, NumPy, Matplotlib, Pandas, sklearn, and the Quandles. Now I have already installed this platform in my Ubuntu server. Now what we are going to do is we are going to import the libraries. So here so we import the libraries like Pandas, Quandle, Math, sklearn. All the libraries has been imported. So now the next step we are going to do is that we are going to load the dataset. Now there are various ways through which we can do that. We can download a dataset or we can use different method. Here what I'm going to do is I'm going to use a Quandle. So let's say Quandle. So let's say I want to predict the stock prices of Google. So let's search for Google. So I get the database from Google Finance. So we have our dataset. So it starts from 2005 till 2016. So what we need is a Quandle code. So let's copy this Quandle code. So after this, let's get the dataset. So let's check whether we have the data or not. So we got our data set. It starts from 2004 and we have 5 columns: open, high, low, close and volume. So in 2004 the stock price for Google was $50 per stock. So if we look at the current, so we have a data till yesterday, so now it has gone to like $817.36 per stock for Google. Now if you like to have a more visualization of the dataset, we can do so easily. So we can have we can plot it. So here we can see. So we can see our data. It goes from 50 to around 850. We can see where is the mean, where most of the values lies, and all those things we can see. And also if we want to have list plot, we can have that. So we have a plot here, bar plot. Similarly, if you have a scatter plot, so we get a scatter plot. Here we can see the relationship between different columns. So we see the relationship between the open and close has a linear relationship. So have a strong relationship between low and open, between high and open, and we can see between volume and open we don't have such a linear relationship. So we can visualize the dataset to know how our dataset actually look like. And if you want to manipulate a dataset, we can also do that. For example, like we saw previously, we have this columns, but if you want like a more useful relationship between the datas, for example, instead of just high and low, we want percentage change between the high and low, similarly between the open and close. So if you want to change this dataset, we can do so. So let's do it. So now what I have done here is I have created a new column, open close change and high low change, so which is like old minus new divided by new, so something like that, like high minus low divided by low. So I have now new columns, and now I can choose like column that I want to see. For example, now I just want the column close, a high low change, open low change and volume. So I have defined this. So now instead of open, high, low, close, I have close, HL change, OC change and volume. So if you want to change the dataset, we can make changes to the dataset. So now let's try to define the features and the labels. So for this, I select a column, closed column, and then what I do is I sift this column by like 10% of the data, and this sift value I put it in another column called a label. So this is like the sifted version of our stock price. So in a way it's like a future value. So we created our label. So if you want to see our label, so if you want to print the labels, we can see we have shifted, so the last value doesn't have any values, and we have shifted the label, our columns. So if you see our data set now, we have a close and we have included a label. So current value doesn't have any value, so let's drop it. So we have created the label, and or the old values are features. So let's define these features and columns, and let's save it in a variable. So in X variable we are keeping only this features value, dropping the label column, and in Y value we have the label. We just make sure that X and Y are of same length. Yeah, same length. Okay, now after this, let's create the train and the testing sets. So we have our features and labels, so using it we are going to create a test and the train set. So we have created a set train and the test, and we have used like 20% of our data for the training. So after we finish creating a train and test set, now we are going to check algorithms through which we are going to do the machine learning. So let's say we are selecting a linear regression. So we have selected a linear regression, so we try to fit it with our train data, but before we use it, we have to make sure that the accuracy of this algorithm works well with our dataset. So here we can see we have like 96% of accuracy, so it seems like this algorithm works well with our dataset. Similarly, if you want to use another algorithm, we can use it. For example, if I want to use, let's say, a vector regression, so if I go there, let me see. Okay. If you want to use vector, so here I have used the vector regression. So if I select the accuracy is very poor, so I'm not using this algorithm. Let's go back to our linear regression. So I have a good accuracy here. So similarly, I can, like, there are various algorithms that I can use. So based on the accuracy of my data set, I can select which algorithm I'm going to use. So right here I'm using the linear regression because I get a quite a good accuracy. So now I have the accuracy for my machine learning. So now I'm just going to predict. So let's start. So I divide my data set into like the new one and the old one, and after that what I'm trying to do is it's very easy with the program. Paste. So I forecast using the new set. I'm trying to forecast it. Boom. So here we have the forecasted value for the next almost like 1 2 3 4 5 5 6 30 30 31 32 days. So I predicted what is going to be the stock price of Google for the like next 30 days. Boom. So if I want to plot this, I think I can plot this one. So if I want to plot this, I can plot this. Boom. So here we can see we have predicted what is going to be the future value. So if I can use this, so this is our predicted value for the future. So in this way we can use the machine learning algorithm to predict the stock prices. So with this I like to conclude my presentation, and I like to thank you all for your time.